In this video here, we will explore the graph of tan, namely the parent graph for tan, which is the most basic one, and we'll explore it between 0 and pi, which is enough for one period. The graph of tan here, if we explore it, refers to the gradient inside the unit circle at any given point. So if we explore what happens at this first point on the right of the unit circle at the bottom there, you can see that the gradient of this line is at 0. So what corresponds here is that first point on the graph, 0, 0. The next point of interest for us is when the gradient is equal to 1. A gradient of 1 is a perfectly diagonal line that goes up and to the right. And at this point here is where the gradient is 1. This occurs at an angle of pi on 4, as we know from our exact values. And as we continue to go up and up and up, our gradient becomes steeper and steeper until we reach a gradient at pi on 2, which is undefined. Now, a gradient that is undefined will present itself as an asymptote. So as soon as you get the asymptote line down, you need to write the equation of the asymptote. In this case here, our parent graph has an asymptote when x is pi on 2. So the behavior of this, as we start from 0 and as we increase up until 1, we will follow this particular curve and it will continue to increase until we approach the asymptote. And it is all positive gradients in the first quadrant here. As soon as we step over, however, to a point on the second quadrant, we notice that our gradient is very steep. However, it is very negative. So our value for tan will begin down here. But let's explore what will happen when we continue to get to a gradient of -1, which occurs at 3 pi on 4 in this case. So the gradient of -1 occurs at 3 pi on 4. So 3 pi on 4 and -1 is there on the graph. And our last point here is at an angle of pi. Our gradient here is flat again, so this corresponds with a value of 0. Now similarly, what happens over here, we will start at a very negative value and we will gradually become flatter and flatter until we reach a value of 0. This is one complete cycle for tan. Now, if we decide to continue with the graph here, we will extend to repeat the same pattern once again. So at this particular point here, our gradient will be 1, which reflects the same kind of behavior over at the beginning, like so. At an angle of 3 pi on 2, we can see that we have an undefined line again, which presents itself as an asymptote. So I'll duplicate that asymptote and bring it over here. But since it's an extension of our actual domain, we'll write that in orange. Once that's done, you can see the pattern of behavior continues on like so. But for our main domain, which is just one period, we'll have a coordinate as 0, 0, pi 0, and this one point here, which is pi on 4 and 1.